Time, one of the most fundamental aspects of our reality, yet one of the least understood. We experience it every day, but we rarely stop to ask, what is time really? We measure it with clocks and calendars, we feel it passing as we grow older, and we structure our lives around it. But is time a real, physical entity? Or is it just an illusion created by our minds? For centuries, humans have tried to define time. The ancient Egyptians, Greeks, and Chinese all developed different ways to track it, using the motion of the sun, moon, and stars. In Newtonian physics, time was seen as an absolute, universal flow, independent of everything else. But Einstein's theory of relativity shattered this idea, showing that time is flexible. It can slow down, speed up, and even stop under certain conditions. But before we dive into the physics of time, let's take a step back and ask a simple question. If all the clocks in the world stopped, would time still exist? Many physicists believe time is simply a way to describe change. Without change, time would have no meaning. Imagine a universe frozen in place. No movement, no interactions. In such a reality, time would be meaningless. But since our world is always in motion, from the orbits of planets to the firing of neurons in our brain, we perceive time as an ever-moving river. Some philosophers and scientists argue that time isn't something that exists independently. It's just a concept we use to understand events. Others believe time is as real as space itself, forming the fabric of the universe. So which is it? Is time just an idea, or is it a fundamental part of reality? One way to approach this question is to look at how different cultures throughout history have understood and measured time. The evolution of timekeeping. The earliest humans measured time by observing the natural world. The cycle of day and night, the changing seasons, and the movement of celestial bodies all gave people a way to structure their lives. The ancient Egyptians were among the first to divide the day into hours. They built sundials, which used the position of the sun's shadow to mark the passage of time. But there was a problem. Sundials only worked during the day. To measure time at night, the Egyptians developed water clocks, where water dripped at a constant rate from one container to another. The Babylonians and Mayans also developed their own ways of tracking time, using star charts and planetary cycles. The Romans later introduced mechanical devices like gears and weights to improve accuracy. But for most of human history, time was measured locally. One village's noon might be slightly different from another's. It wasn't until the invention of railroads in the 19th century that people needed a standardized system. Before trains, every town had its own local time, based on the sun's position. But with trains traveling across multiple regions, this became impractical. So in 1884, the world agreed on a system of time zones, dividing the planet into 24 regions, each with its own synchronized time. Today, we rely on atomic clocks, which use the vibrations of cesium atoms to measure time with extreme precision. These clocks are so accurate that they lose less than a second over millions of years. Without them, technologies like GPS and satellite communications wouldn't work. But as our ability to measure time has improved, so has our understanding of what time actually is. And that's where things get strange. The mystery of time. Is it real or an illusion? For most of history, time was thought to be absolute, a universal constant that flows at the same rate everywhere. This idea was championed by Sir Isaac Newton, who saw time as a cosmic clock, ticking forward independently of everything else. But in the early 20th century, Albert Einstein discovered something shocking. Time is not absolute, it is relative. Einstein's theory of relativity showed that time is linked to speed and gravity. The faster you move, the slower time passes for you. Similarly, strong gravitational fields, like those near black holes, can stretch and warp time. This means that time does not flow the same way for everyone. This has been proven with experiments using atomic clocks placed on high-speed airplanes. When the clocks were compared to identical ones left on the ground, the ones on the airplanes had experienced slightly less time. The difference was tiny, but it confirmed Einstein's predictions. This raises an incredible question. If time is relative, does that mean past, present, and future all exist at once? According to some physicists, the answer is yes. The block universe theory suggests that all moments in time exist simultaneously. It's only our perception that makes it seem like time flows forward. Imagine a DVD of a movie. All the scenes exist at the same time, but you can only experience them one at a time. Some scientists believe reality works the same way. If that's true, then what we perceive as the present is just an illusion created by our consciousness. The past hasn't disappeared, and the future isn't something we haven't reached yet. It all exists at once. But if this is true, why do we only experience time moving forward? Why can we remember the past but not the future? The answer may lie in entropy, the tendency of systems to move from order to disorder. Entropy, the reason. Time moves forward. Imagine dropping a glass on the floor. It shatters into pieces and you can't put it back together without effort. This is because entropy, a fundamental law of thermodynamics, ensures that the universe always moves toward greater disorder. This may be why time seems to move in only one direction. In physics, the past and future are mathematically identical, meaning there's nothing in the equations that forces time to move forward. But in reality, we always see things moving from order to chaos, not the other way around. Entropy explains why we remember the past but not the future. Our brains are information processing systems, and they store memories of events that have already happened. But the future hasn't unfolded yet, at least not from our perspective, so we can't remember it. This concept is still being debated, but it may hold the key to understanding why time feels linear, even if it isn't. From the earliest days of civilization, humans have been obsessed with measuring time. The passage of the sun, the waxing and waning of the moon, and the shifting of the stars provided the first natural clocks. But why did ancient societies feel the need to track time in the first place? The answer lies in survival, organization, and an innate human desire to impose order on the world. In the ancient world, timekeeping wasn't about tracking hours and minutes. It was about knowing when to plant crops, when to prepare for winter, and when to hold rituals and ceremonies. The earliest calendars were based on the cycles of the moon and the stars. The Babylonians, Egyptians, and Chinese each developed different ways to track time, all rooted in the movement of celestial bodies. One of the oldest known timekeeping methods is the sundial, used by the Egyptians as early as 1500 BCE. By tracking the movement of a shadow cast by a stick or obelisk, they could divide the day into periods of light and darkness. However, sundials only worked during the day. At night, early civilizations turned to water clocks, devices that used a steady drip of water to measure time. The Chinese and Greeks refined this method, creating intricate systems that allowed for more precise measurements. While sundials and water clocks provided rough estimations, they were far from accurate by modern standards. The real breakthrough in timekeeping came with the development of mechanical clocks in the Middle Ages. Early tower clocks, built in European churches and cathedrals, used weights and gears to move their hands. These massive machines weren't just practical, they were symbols of power and control, as the ability to track time became closely linked with religious and political authority. For most of history, time was measured locally. There was no universal standard. Each city or region had its own system, often tied to the position of the sun. A town's noon was determined by when the sun was at its highest point in the sky, meaning that different places had slightly different times. This wasn't a problem until the invention of railroads. In the early 19th century, rail travel became widespread, allowing people to move between cities faster than ever before. But there was a problem. With each town using its own local time, scheduling trains became a logistical nightmare. A train leaving one city at noon might arrive at another city where the local time was 12:15. To solve this, countries introduced standard time zones, synchronizing clocks across regions. The system we use today, dividing the world into 24 time zones, was established in 1884 at the International Meridian Conference. Standardizing time didn't just affect train schedules, it changed how people experienced time itself. In earlier centuries, life was dictated by natural rhythms, the rising and setting of the sun, the seasons, the cycles of agriculture. But with industrialization, time became something rigid and mechanical. The clock, once a tool for monks and astronomers, now controlled the daily lives of workers, schoolchildren, and businesses. The transition from natural time to industrial time had profound effects on society. Factories operated on strict schedules, with shifts and breaks regulated by the ticking of the clock. Schools adopted fixed start and end times. Even leisure activities became structured around time. People began planning their days around television broadcasts, train departures, and later, the availability of internet access. Today, time is measured with incredible precision. Modern atomic clocks, which rely on the vibrations of cesium atoms, are accurate to 1 second every 100 million years. These clocks are so precise that they are used to synchronize GPS satellites, ensuring accurate navigation. Without atomic timekeeping, many of the technologies we rely on daily, smartphones, satellites, financial transactions, wouldn't function properly. But despite all our advancements in measuring time, we are still faced with fundamental questions. What is time really? Is it something we create, or is it something that exists independently of us? These questions lead us into the fascinating world of physics, where time becomes even stranger than we ever imagined. For centuries, time was thought to be an absolute, unchanging force. The idea was simple: time flows at a steady rate, like a cosmic clock ticking forward, independent of everything else. This concept was championed by Sir Isaac Newton, who believed that time was the same everywhere, always moving at a fixed rate, unaffected by space or motion. Newton's view of time was intuitive. It matched human experience. Whether you were standing still or running, time seemed to pass the same way. Whether you were on Earth or traveling through the cosmos, a second was always a second. In Newton's world, time was like a vast, invisible river, carrying everything along at a uniform speed. For centuries, scientists accepted this idea without question. But in the early 20th century, a young patent clerk named Albert Einstein changed everything. His theory of relativity shattered the Newtonian concept of absolute time and replaced it with something far more bizarre. Time is not constant, it is relative. Einstein discovered that time is linked to two things: speed and gravity. The faster you move, the slower time passes for you. Similarly, the stronger the gravitational field you are in, the more time slows down. This isn't just a theory, it has been confirmed in multiple experiments. One of the most famous tests of Einstein's relativity involved atomic clocks placed on airplanes. Scientists took highly precise clocks and placed one on a plane flying around the Earth, while another identical clock remained on the ground. When the plane landed, the clock on board had measured slightly less time than the clock on Earth. Even though the difference was tiny, it confirmed Einstein's prediction. Motion slows time down, but relativity goes even further. According to Einstein, time and space are part of the same fabric, known as space-time. Imagine space-time as a massive, flexible sheet. When a heavy object like the sun sits on this sheet, it creates a curve, bending space-time around it. This warping of space-time affects how time flows. Closer to massive objects like stars or black holes, time slows down significantly. This effect is known as gravitational time dilation. Near a black hole, where gravity is incredibly strong, time slows down so much that someone orbiting close to the event horizon might experience only a few minutes, while years pass for someone farther away. This concept was famously portrayed in the movie Interstellar, where astronauts visiting a planet near a black hole experienced only a few hours, while decades passed for those waiting on their ship. But if time can slow down, does that mean it can also stop? In theory, yes. According to Einstein's equations, if an object could reach the speed of light, time would completely stop for that object. This means that, from the perspective of a photon traveling through space, time doesn't exist at all. Einstein's discoveries raised profound questions about the nature of time. If time is flexible and can be altered by speed and gravity, then does that mean past, present, and future are all equally real? Some scientists believe the answer is yes, leading to a controversial idea known as the block universe theory. This theory suggests that all moments in time exist simultaneously. It is only our perception that creates the illusion of time flowing forward. This idea is deeply unsettling because it challenges the way we experience reality. If all points in time already exist, then does that mean free will is an illusion? Are we simply moving along a predetermined path? unaware that the future has already been written. Newton and Einstein's competing views on time represent one of the greatest shifts in scientific thought. Newton saw time as absolute and unchanging, while Einstein proved that time is relative and malleable. But despite Einstein's breakthroughs, the nature of time remains one of the biggest mysteries in physics. As we explore deeper, we begin to ask even stranger questions. If time can slow down and stretch, could it be possible to travel through time itself? If time can speed up, slow down, and even stop under certain conditions, then we have to ask, is time even real? Or is it just an illusion created by our minds? Some scientists and philosophers argue that time doesn't exist in the way we think it does. Instead, it might be nothing more than a way for our brains to organize events. Albert Einstein himself once said, "The distinction between past, present, and future is only an illusion, however persistent." According to his theory of relativity, time is just another dimension, like width, height, and depth. We experience it as moving forward, but in reality, the past, present, and future all exist simultaneously. This idea is known as the block universe theory. Imagine the universe as a massive block with every event that has ever happened or will ever happen already existing within it. In this view, time doesn't flow forward. It just is. We only experience time moving forward because that's how our consciousness perceives it. If this is true, then the future is already written. It just hasn't happened from our perspective yet. This challenges everything we think we know about free will. If all events exist at once, do we really make choices? Or are we just following a script that has already been set in stone? Some scientists believe this theory explains certain strange phenomena in quantum mechanics. In the quantum world, particles can exist in multiple states at once, and their behavior seems to change depending on whether or not they are observed. Some physicists have suggested that future events might be able to influence the past, something that would be possible if all points in time already exist. But if time is an illusion, why does it feel so real? Why do we remember the past but not the future? The answer may lie in entropy, a concept from thermodynamics that describes the natural tendency of systems to move from order to disorder. Think about breaking a glass. Once it shatters, you can't put it back together without effort. This is because entropy always increases over time. The second law of thermodynamics states that systems naturally move toward greater disorder, and this may be why we perceive time as flowing forward. In other words, we experience time as moving in one direction because the universe is constantly becoming more chaotic. If entropy worked in reverse, we might perceive time differently. This idea suggests that time isn't a fundamental property of the universe. It's just a byproduct of how the universe evolves. But what if our experience of time is simply a limitation of human consciousness? Some theories suggest that time might not exist at all. It could just be a way our brains interpret changes in the world. Consider dreams. When we dream, we can experience long, detailed events in what feels like hours, yet in reality, only minutes have passed. Our brains are capable of stretching or compressing time depending on the situation. If time were truly objective, this wouldn't be possible. Experiments in neuroscience have also shown that our perception of time can be manipulated. Studies have found that when people are exposed to unexpected or high-stress situations, time seems to slow down. This is because the brain records more details, making the experience feel longer than it actually is. Some researchers believe this could explain near-death experiences, where people report their entire lives flashing before their eyes. It's not that time slows down, it's that the brain is rapidly processing information, creating the illusion of extended time. So, is time real, or is it just a trick of the mind? The answer might depend on how we define real. From a scientific standpoint, time behaves in strange and unpredictable ways, but from a human perspective, time is the foundation of how we experience life. Even if time is an illusion, it is an illusion that shapes everything we do. It determines our past, our future, and the very way we perceive reality. But if time can be bent, stretched, and even stopped, could it be possible to travel through time itself? If time is an illusion, then why does it feel so real? Why does a single moment of pain feel like it lasts forever, while years can pass in the blink of an eye? The answer lies not in physics, but in our brains. Time is not something we pass through. It is something we perceive. Our brains do not measure time like a clock does. Instead, they construct time based on sensory input, emotions, and memory. This is why two people experiencing the same event can perceive its length differently. A thrilling roller coaster ride might feel too short for one person, but unbearably long for another. Neuroscientists have discovered that our sense of time is not controlled by a single part of the brain. Instead, it is managed by multiple areas, including the cerebral cortex, the basal ganglia, and the cerebellum. These regions work together to create our experience of time. One of the most fascinating aspects of time perception is how our brain stretches or compresses it depending on the situation. Have you ever noticed that when you are bored, time drags, but when you are fully engaged, time flies? This happens because the brain records more details when we are paying attention, making a moment feel longer. Scientists call this the oddball effect. When we encounter something new or surprising, time seems to slow down. Imagine driving and suddenly seeing another car swerving into your lane. In that moment, time appears to slow. Your brain captures more details, stretching your perception of time so that you can react faster. This effect is also why childhood feels so much longer than adulthood. When we are young, everything is new. Our brains are constantly learning, making time feel stretched out. But as we age, fewer things surprise us. Routine takes over, and with fewer new memories being stored, our perception of time speeds up. But what if we could control our experience of time? Could we slow it down or speed it up at will? Some studies suggest that we can. Researchers have found that meditation and mindfulness practices can alter how we perceive time. By focusing on the present moment, people report feeling as if time expands, allowing them to experience more within the same period. This suggests that our experience of time is not fixed. It can be shaped by our state of mind. In extreme cases, some people have reported losing their sense of time entirely. This happens in flow states, a mental condition where people are so deeply immersed in an activity that time seems to vanish. Athletes, musicians, and even gamers often experience this. They might play for hours but feel like only minutes have passed. If time is just a construct of the brain, then does that mean it could be manipulated further? Could it be possible to experience time at different speeds, or even reverse our perception of it? Some researchers believe that memory plays a key role in how we perceive time. When we recall events, our brains reconstruct them rather than replaying them like a video. This means our memories are constantly changing, which can alter how long we think events lasted. In some cases, brain injuries or neurological conditions can distort time perception entirely. People with certain types of brain damage may experience time lapses, where hours feel like seconds or vice versa. Others may lose their ability to track time at all, living entirely in the present moment without a sense of before or after. These findings suggest that our experience of time is far more flexible than we might think. If time can stretch, compress, and even disappear depending on brain function, then it raises a profound question. If our perception of time is unreliable, then how can we trust that time exists at all? If you've ever felt like time is speeding up as you get older, you're not alone. Many people report that childhood summers felt endless, but as adults, entire years seem to pass in the blink of an eye. But why does this happen? Is time really moving faster, or is it just an illusion created by our brains? One of the most widely accepted explanations is the proportional theory. When you are 5 years old, a single year represents 20% of your entire life. That's a massive fraction. But by the time you turn 50, a single year is only 2% of your life. Because each new year becomes a smaller fraction of your total experience, it feels shorter by comparison. Another explanation comes from the novelty effect. When we are young, everything is new. Our brains are constantly processing new experiences, storing more details, and forming more memories. These fresh experiences make time seem stretched out. But as we grow older, routine takes over. We drive the same routes, eat the same foods, and experience fewer new things. Since our brains don't need to record as many new details, time seems to speed up. Studies have shown that the more memories we create, the longer time feels. This explains why time seems to slow down during exciting or unusual experiences. A 2-week vacation in a foreign country might feel much longer than 2 weeks of doing repetitive office work because your brain is encoding new information at a much higher rate. This effect is also why near-death experiences are often described as happening in slow motion. When faced with danger, the brain records more details, making the experience feel stretched out. Soldiers in combat and people involved in car accidents have reported feeling like time slowed down, even though everything was happening at normal speed. Experiments have proven that our perception of time is directly linked to our experiences. In one study, participants were shown a series of identical images followed by a single oddball image. When asked how long each image was displayed, people consistently reported that the oddball image lasted longer than the others, even though all images were shown for the exact same amount of time. This suggests that the brain slows down time when it encounters something unexpected. So, if routine speeds up time and novelty slows it down, does this mean we can trick our brains into making time feel longer? Some researchers believe we can. By deliberately seeking out new experiences, we can slow down our perception of time. Traveling to new places, learning new skills, and even taking a different route to work can force the brain to process more details, making time feel richer and more expansive. This idea is supported by research on mindfulness and meditation. People who practice mindfulness often report feeling like they have more time. By focusing on the present moment instead of rushing through daily life, they slow down their brain's processing speed, effectively stretching time. But what if the opposite happens? What if time doesn't just feel faster as we age, but actually accelerates in reality? Some physicists have proposed that time itself might be gradually speeding up on a cosmic scale. If true, this could have profound implications for the way we understand the universe. Whether time is truly speeding up or not, one thing is clear. Our perception of time is deeply tied to our experiences. If we want to make life feel longer, we need to fill it with novelty, excitement, and moments that break routine. But what if we could do more than just change our perception of time? What if we could actually travel through time itself? For centuries, time travel has fascinated scientists, philosophers, and storytellers alike. From H.G. Wells's The Time Machine to Hollywood films like Interstellar and Back to the Future, the idea of jumping forward or backward in time has captured the human imagination. But is time travel just science fiction, or could it be possible within the laws of physics? According to Einstein's theory of relativity, time travel isn't just a fantasy. It's a real, scientifically supported concept. But before we get too excited, it's important to clarify one thing. Time travel isn't as simple as stepping into a machine and pressing a button. Instead, it requires bending the very fabric of space-time itself. One of the most well-documented forms of time dilation is the fact that traveling at high speeds slows time down. This has been proven through experiments with atomic clocks. When one clock is placed on a high-speed airplane and another remains on the ground, the airborne clock moves slightly slower than the one on Earth. But this effect becomes even more dramatic when approaching the speed of light. According to relativity, the faster you move, the slower time passes for you. If you were to travel on a spaceship moving at 99% the speed of light, time for you would slow down compared to someone on Earth. A journey that feels like a few years for you might be centuries for those left behind. This means that, in a way, traveling into the future is already possible. It just requires extreme speeds that we can't yet achieve with current technology. But what about traveling to the past? This is where things become far more complicated. Some physicists believe that wormholes, theoretical shortcuts through space-time, could allow for backward time travel. A wormhole, also called an Einstein-Rosen bridge, is like a tunnel that connects two distant points in space and time. If one end of a wormhole were placed near a black hole, where gravity slows time dramatically, and the other end remained in normal space, traveling through it might allow a person to move backward in time. However, there are several major problems with using wormholes for time travel. We have never observed a wormhole in reality. They remain purely theoretical. Even if they exist, they might be extremely unstable. The moment anything enters them, they could collapse. Time paradoxes could arise. If someone traveled back in time and changed something significant, it could create logical contradictions, like the famous grandfather paradox, where someone goes back in time and prevents their own existence. This paradox has led some scientists to propose the Novikov self-consistency principle, which suggests that the universe prevents paradoxes from occurring. According to this principle, if time travel to the past were possible, history would always correct itself to prevent contradictions. This would mean that even if you traveled to the past, you couldn't change anything that would prevent your original timeline from existing. Some theories, however, suggest that changing the past could create alternate realities rather than paradoxes. In this view, traveling back in time wouldn't overwrite history, but would instead create a new branching timeline, separate from the one you left. This is a concept often explored in science fiction, but it's also a possibility in quantum mechanics, where multiple possible outcomes exist simultaneously until observed. At the quantum level, particles can exist in multiple states at once, suggesting that reality might be more flexible than we think. Some physicists believe that time itself might be quantized, meaning that what we perceive as a smooth flow of time is actually made up of tiny, indivisible moments, just like frames in a film. If time does work this way, then manipulating it might be more plausible than we previously thought. But even if we could one day build a real time machine, there's another problem. Would we even be able to survive the journey? The energy required for any form of time travel, whether through wormholes or near light-speed travel, would be immense. Additionally, the effects of extreme time dilation or exposure to intense gravitational fields could make time travel lethal for humans. Despite these challenges, scientists continue to study time travel seriously. Even if backward time travel remains impossible, forward time travel is already a proven reality, just at a microscopic scale. So, is time travel possible? To the future, yes. To the past, maybe. The answer may depend on whether we can unlock the deeper mysteries of black holes, quantum mechanics, and the very structure of space-time itself. If time is relative and can slow down or speed up depending on gravity and motion, then where does this effect become most extreme? The answer lies in one of the most mysterious objects in the universe: black holes. Black holes are formed when a massive star collapses under its own gravity, creating a point in space with such intense gravitational pull that nothing, not even light, can escape. But black holes don't just warp space. They also warp time. According to Einstein's general theory of relativity, the closer you are to a massive gravitational source, the slower time moves for you. This means that if you were to approach a black hole and hover near its event horizon, the point of no return, time for you would slow down dramatically compared to someone observing from far away. Imagine a person watching you from a safe distance while you descend toward a black hole. From their perspective, you would appear to slow down, moving in extreme slow motion. In fact, if you could hover just above the event horizon indefinitely, time for you would practically stop. This means that black holes are natural time machines. In theory, an astronaut orbiting close to a black hole for a few hours could return to find that centuries have passed for the rest of the universe. This kind of time dilation isn't just a theoretical idea. It has already been observed on a much smaller scale. For example, satellites orbiting Earth experience tiny amounts of gravitational time dilation due to Earth's gravity. GPS satellites have to be constantly corrected for time differences compared to clocks on the ground. Without these adjustments, GPS calculations would be inaccurate by kilometers within just a day. But black holes take this to an extreme. The larger the black hole, the greater the time dilation effect. If someone were to enter a supermassive black hole, which contains millions or billions of times the mass of our sun, they could experience minutes while thousands of years pass in the universe outside. This idea was famously depicted in the movie Interstellar, where the crew visits a planet orbiting close to a massive black hole. Due to the immense gravity, every hour on the planet equaled 7 years outside. While this may seem like science fiction, it's based on real physics. But what happens if you go beyond the event horizon? According to Einstein's equations, once you cross that boundary, there's no escape. The gravitational pull is so strong that even light cannot get out, meaning that all information is lost to the outside universe. Some physicists, however, believe that information might not be completely lost. The famous black hole information paradox suggests that black holes may not entirely erase matter and energy. They could store or even release it in ways we don't yet understand. Some researchers propose that black holes might act as gateways to other parts of the universe, or even other universes. This concept, though speculative, suggests that black holes could be connected to wormholes, theoretical tunnels through space-time that might allow for shortcuts between distant points in the universe. If wormholes do exist, they could potentially be used for time travel. By placing one end of a wormhole near a strong gravitational source like a black hole and keeping the other in normal space, time could flow differently at each entrance. This means that stepping into one side could send you into the past or future relative to the other. However, wormholes come with a major problem. They are highly unstable. The moment any matter tries to pass through, the tunnel might collapse. Some scientists believe that exotic forms of energy, such as negative energy, could stabilize wormholes, but this remains purely theoretical. Despite these challenges, black holes remain one of the most fascinating and mysterious objects in the universe. They are time-warping cosmic giants, demonstrating just how strange and flexible time really is. If time can slow down near black holes, could it also move backward? What prevents us from reversing time? And why do we only experience it moving in one direction? If time can slow down, stretch, and even stop under the right conditions, then why can't it go backward? Why do we always experience time moving forward, from past to future, and never in reverse? This is one of the biggest unsolved mysteries in physics. According to the fundamental laws of physics, most equations work equally well forward and backward. Whether a particle moves forward in time or backward, the equations describing its motion remain the same. This suggests that nothing in physics explicitly prevents time from running in reverse. And yet, in the real world, we never see time moving backward. A shattered glass never reassembles itself. Smoke never goes back into a cigarette. A person never grows younger. Why? The answer may lie in a concept called entropy, the measure of disorder in a system. Entropy and the one-way flow of time. In 1850, physicist Rudolf Clausius formulated the second law of thermodynamics, which states that in any closed system, entropy always increases over time. This means that the universe naturally moves from order to disorder. Imagine dropping a deck of cards on the floor. The cards scatter in random directions, creating disorder. You could, in theory, pick up the cards and organize them again, but that requires energy and effort. The natural tendency is always toward disorder, not order. This is why we never see broken objects spontaneously fixing themselves. The universe is constantly moving toward a state of higher entropy, meaning that the past is always more ordered than the future. This increasing entropy gives rise to what scientists call the arrow of time, the one-way direction in which we experience time. But if entropy is the reason time moves forward, does that mean that if we could reverse entropy, we could reverse time? Could we reverse time? In theory, yes. If we could somehow find a way to decrease entropy, we might be able to experience time running backward. However, in our universe, entropy always increases, making this nearly impossible on a large scale. That said, there are some strange exceptions. In the quantum world, where particles behave unpredictably, some processes do appear to reverse themselves. Scientists have observed time reversal symmetry in certain quantum systems, where tiny particles behave as if they are moving backward in time. This has led some researchers to wonder, could time reversal happen on a larger scale? Could we one day develop technology that allows us to reverse entropy and experience time backward? One theoretical idea involves using negative energy, a concept from quantum physics that suggests that certain exotic particles might have negative mass. Some physicists believe that negative energy could be used to stabilize wormholes, potentially allowing information or even people to move backward in time. But even if we could reverse time, there's another problem: our memories and consciousness. Would we remember time running backward? Imagine that time suddenly reversed. Would we realize it? Or would our memories also be reversed, making everything seem normal to us? Some scientists suggest that if time did reverse, we wouldn't even notice it. Our thoughts, emotions, and actions would all be playing in reverse as well, meaning we would never experience anything unusual. This brings us back to the block universe theory, which suggests that all moments in time already exist, and that the flow of time is just an illusion created by our consciousness. If this is true, then reversing time wouldn't change anything. It would just be another perspective within the fixed structure of space-time. So while physics does not strictly forbid time travel to the past, the increasing entropy of the universe ensures that, for now, we can only move forward. But what happens when the universe runs out of time? What does the ultimate fate of time look like? So far, we've explored time from the perspective of classical physics and relativity. But what happens when we look at time on the smallest possible scale? The quantum world. Quantum mechanics describes the behavior of subatomic particles, the tiny building blocks of the universe. And in this strange world, time doesn't work the way we expect. One of the strangest discoveries in quantum physics is that particles don't seem to experience time the way we do. In classical physics, if you know an object's position and speed, you can predict where it will be in the future. But at the quantum level, this is impossible. According to the Heisenberg uncertainty principle, the more precisely we measure a particle's position, the less we know about its speed, and vice versa. This suggests that the future of a quantum particle is not set in stone. It exists in multiple possible states at once until it is observed. This phenomenon is demonstrated in the famous double-slit experiment. When scientists shoot particles at a screen with two slits, the particles behave as if they are in multiple places at once, creating an interference pattern like a wave. But the moment scientists observe which slit the particle goes through, the pattern disappears, and the particle acts like a single object again. This raises a profound question. Does time only exist because we observe it? If quantum particles exist in a superposition of states, where multiple possibilities exist at once, then could the same be true for time itself? Some physicists believe that the past, present, and future may all exist as probabilities until they are observed by consciousness. This could mean that time is not a fundamental part of reality, but rather something that emerges when we interact with the world. This idea connects with the controversial quantum timelessness hypothesis, which suggests that time may not exist at the deepest level of reality. Instead of time flowing from past to future, the universe may be more like a static structure, with everything, past, present, and future, existing at once. But if time is not fundamental, then why do we experience it? Some physicists argue that time is an illusion created by our limited perspective. In this view, just as a fish living in a pond might only perceive its small environment without realizing it's inside a larger body of water, we might only perceive time as a flowing experience because we are trapped within it. This idea is supported by certain interpretations of quantum gravity, the field that tries to unify Einstein's relativity with quantum mechanics. Some theories, such as loop quantum gravity, suggest that time is not continuous but made up of discrete, tiny moments, like frames in a movie. If this is true, then what we think of as the present is just the result of many tiny quantum fluctuations happening one after another. But if time is an illusion, then what happens at the end of time? What does the future hold for the universe itself? Will time continue forever, or will it one day stop? Some theories suggest that time could cease to exist under certain conditions, such as in the final moments of the universe. Others propose that new universes could emerge from the remnants of the old, resetting time in an infinite cycle. This takes us to our next question. What is the ultimate fate of time and the universe? For thousands of years, humanity has been refining the way we measure time. From sundials and water clocks to mechanical timepieces, and now to atomic clocks, our ability to track time has become incredibly precise. But as our understanding of physics advances, could we discover even more accurate ways to measure time? The evolution of timekeeping. The first major breakthrough in time measurement came with mechanical clocks in the Middle Ages. These clocks, driven by gears and pendulums, were a massive improvement over earlier methods, but still had errors of several minutes per day. The next leap forward came with quartz clocks in the 20th century. Instead of relying on mechanical movements, quartz clocks use an electronic oscillator regulated by the vibration of a quartz crystal. This made them thousands of times more accurate than mechanical clocks. But the real revolution came with the atomic clock, which doesn't rely on physical gears or vibrations, but instead measures time based on the oscillation of atoms. The most precise atomic clocks use cesium-133 atoms, which vibrate at an incredibly stable frequency. These clocks are so accurate that they lose or gain less than 1 second every 100 million years. Why do we need more accurate clocks? At first, it might seem unnecessary to have clocks this precise. After all, do we really need to measure time to the billionth of a second? But ultra-precise timekeeping is essential for modern technology. GPS satellites. The GPS system in your phone works by receiving signals from satellites orbiting the Earth. These satellites rely on atomic clocks to synchronize their signals. If their timekeeping were off by even a fraction of a second, GPS calculations would become inaccurate by kilometers. Financial markets. High-frequency trading systems rely on nanosecond-level precision to execute transactions worth billions of dollars. Scientific research. Precise timekeeping is crucial in physics, astronomy, and space exploration. Without it, studying gravitational waves, synchronizing telescopes, and even tracking particle movements in quantum experiments would be impossible. The next generation, optical clocks. Despite how accurate atomic clocks are, scientists are now working on something even more advanced: optical clocks. Instead of using cesium atoms, optical clocks use elements like ytterbium or strontium, which oscillate at much higher frequencies. These clocks are expected to be 100 times more accurate than current atomic clocks, potentially losing just 1 second over the entire age of the universe. But even as we improve time measurement, we must ask a deeper question. Are we measuring something fundamental, or are we just refining an illusion? Some physicists believe that time itself may be an emergent property, not a fundamental aspect of reality. If that's true, then no matter how precisely we measure time, we are still only observing a construct created by the universe itself. If time is just a construct, could it one day stop altogether? And if it does, what would that mean for the future of the universe? If time is something we measure, experience, and perceive, then what happens at the end of time? Will time continue forever? Or is there a moment when time itself ceases to exist? To answer this, we must explore the ultimate fate of the universe. The universe is constantly changing. Galaxies are moving apart, stars are dying, and new ones are forming. But this process won't continue forever. Scientists have proposed several theories about how the universe will end, and each one has a different implication for time itself. 1. The Big Freeze, when time loses meaning. One of the most widely accepted theories is the Big Freeze, also known as heat death. In this scenario, the universe continues expanding forever. As galaxies drift further apart, stars burn out, and the universe runs out of usable energy. Eventually, all activity slows down until nothing is left but cold, dark emptiness. At this stage, time would still exist, but it would be meaningless. With no change occurring, no movement, and no observers to experience it, time would essentially stand still. There would be nothing left to mark its passage. No stars, no planets, no life. This scenario aligns with the second law of thermodynamics, which states that entropy, the measure of disorder, always increases. Eventually, entropy reaches its maximum, meaning no energy is left to create order, structure, or motion. Without change, there is no meaningful distinction between past, present, or future. Would time end, or would it just become irrelevant? Some physicists argue that in a universe without change, time might as well not exist. 2. The Big Crunch. Time runs in reverse? Another possibility is that the universe won't expand forever, but instead stop and collapse back in on itself. This is called the Big Crunch. If gravity is strong enough to eventually overcome the expansion, everything will start pulling inward. Galaxies, stars, and even space itself would shrink, condensing back into an incredibly hot, dense point, just like the state of the universe before the Big Bang. Some scientists believe that if the Big Crunch happens, time itself might reverse. Just as the universe expanded outward after the Big Bang, it could contract in a mirrored way. If this were true, people might experience events backward, seeing their lives play out in reverse. But this raises another question. Would we even notice? If time were truly reversed, our thoughts, memories, and perception would also be reversed. we would have no way of realizing that anything had changed. 3. The Big Rip. Time torn apart. A more dramatic ending for the universe is the Big Rip. This theory suggests that the expansion of the universe is not just continuing, it's accelerating. If this acceleration keeps increasing, then at some point in the distant future, even the fundamental forces holding atoms together could be ripped apart. First, galaxies would separate. Then, solar systems would be torn away from their stars. Planets would disintegrate. Eventually, even atoms and subatomic particles would be torn apart. In this scenario, time wouldn't just slow down or speed up. It would be destroyed entirely, along with the fabric of space-time itself. The laws of physics as we know them would cease to function, and there would be no way to measure or experience time anymore. 4. The cyclic universe. Does time restart? Some physicists suggest that time never truly ends. It resets. In the cyclic universe theory, the universe goes through endless cycles of expansion and contraction. The Big Bang wasn't the beginning of everything, but just the latest phase in an infinite loop. If this theory is correct, time doesn't have an end. It simply resets, and a new universe begins. This would mean that our reality might have existed before and will exist again in the future. However, there's no way to prove whether each cycle is identical or if every new universe unfolds differently. 5. The quantum fate. Time is just an illusion. Some of the strangest ideas about time's fate come from quantum mechanics. Certain quantum gravity models suggest that time isn't a fundamental property of the universe at all. Instead, it emerges from deeper quantum processes. If this is true, then at the universe's final moments, time might simply dissolve. Not because the universe is collapsing or freezing, but because it never really existed in the first place. What does this mean for us? If time stops, reverses, or resets, what happens to our consciousness? Do we simply cease to exist, or does something else take place beyond time itself? The answer to this question is still unknown. But if time is just a construct of our perception, then perhaps what we call the end of time is nothing more than a transition to something beyond our understanding. Regardless of how the universe ends, one thing is certain. Our experience of time is fleeting. If time is limited, whether for individuals, civilizations, or the entire universe, then perhaps the most important lesson is to make the most of the moments we have. But is it possible that we could escape the flow of time entirely? Could we break free from the limitations of mortality, or even create a reality where time no longer controls us? If time is the force that governs all existence, is there any way to escape it? Could we break free from aging, mortality, or even the limitations of time itself? For centuries, humans have dreamed of immortality. Ancient legends tell of the fountain of youth, elixirs that grant eternal life, and gods who exist outside of time. But today, scientists and philosophers are asking a more serious question. Can technology or science actually free us from time's grip? The quest for biological immortality. One way to escape time's effects is to stop aging altogether. Currently, the human body follows a biological clock. Cells age, DNA deteriorates, and eventually, organs fail. But what if we could slow or even reverse the aging process? Scientists have already made breakthroughs in this area. Research into telomeres, the protective caps on the ends of our chromosomes, suggests that aging is not inevitable. Telomeres shorten over time, leading to aging and death. But experiments have shown that lengthening telomeres can rejuvenate cells, at least in laboratory settings. Then there's the field of biological reprogramming, where scientists use gene editing to restore old cells to a younger state. Studies on mice have shown that reversing cellular aging is possible. Could humans one day live for hundreds or even thousands of years? Some futurists believe that aging will eventually be treated as a disease, one that can be cured with advanced medicine, genetic engineering, or nanotechnology. If this happens, then for the first time in history, time's effect on the body could be slowed or even stopped. But even if we achieve biological immortality, we are still trapped in time. No matter how long we live, we would still experience time moving forward. What if we could take a different route? One that frees us from time entirely? Uploading consciousness, a digital escape from time. Another idea for escaping time is to transfer human consciousness into a digital form. This concept, known as mind uploading, suggests that if we can fully map the human brain, we could simulate it on a computer. In theory, a person's consciousness could be transferred to a digital world where time could be manipulated, or even eliminated entirely. This idea is already being explored by scientists and tech entrepreneurs. Some researchers believe that by the end of this century, we might be able to scan a human brain at such high resolution that we could recreate a digital version of a person's mind. If successful, this would mean that a version of you could exist outside of biological time. In a digital environment, time would no longer be fixed. It could be paused, sped up, or slowed down. People could choose to live in a world where time has no meaning, where seconds feel like centuries, or where entire lifetimes can pass in an instant. But if we could upload our minds into a simulated world, how would we know we're not already in one? Are we already in a simulation? Some physicists and philosophers have proposed that we might already be living inside a computer simulation, a digital reality controlled by an advanced intelligence outside of time. This idea, known as simulation theory, suggests that if future civilizations develop the ability to create realistic virtual worlds, they would likely create millions or even billions of simulated universes. If that's the case, then statistically speaking, our reality is more likely to be a simulation than the original universe. One of the most famous arguments for simulation theory comes from philosopher Nick Bostrom, who proposed three possibilities. Civilizations never reach the stage of creating realistic simulations because they go extinct first. Advanced civilizations exist, but choose not to create simulated worlds. Advanced civilizations do create simulations, and we are likely inside one. If option 3 is true, then our perception of time is artificial, something programmed into the simulation. In this case, time isn't a universal force. It's just an illusion designed to make the simulation feel real. Some scientists believe that future research into quantum mechanics or cosmic background radiation might reveal glitches in reality, evidence that we are inside a programmed system. If time is just a construct within a simulation, then it raises an even deeper question. Who created it, and why? Would escaping time mean escaping the simulation? Or would it simply place us into another layer of reality, one with its own version of time? Escaping time, a cosmic perspective. Whether through biological immortality, digital consciousness, or escaping a simulated world, the idea of freeing ourselves from time fascinates the human mind. But perhaps the real lesson is that our experience of time is what makes life meaningful. If we had infinite time, would anything still matter? Would love, achievements, and human experiences still feel significant? Or is it the temporary nature of time that gives life its value? As we explore the nature of time, we are left with profound questions. If time is an illusion, is anything truly permanent? And if time can be escaped, what comes next? If time is something we experience, measure, and even attempt to escape, then we must ask one final question. Will time ever end? Throughout history, cultures and religions have explored the concept of the end of time. Some traditions describe an apocalyptic event that brings time to a halt, while others suggest that time is cyclical, endlessly repeating in a cosmic loop. But what does modern science say? Could time simply stop? At first glance, the idea of time stopping might seem impossible. As long as the universe exists, shouldn't time continue? However, several scientific theories suggest that time may not be eternal. As we discussed earlier, the Big Freeze predicts that as the universe expands, it will eventually reach a point where no more energy can be used to sustain movement, heat, or life. In this scenario, time would lose all meaning. If nothing is happening, no motion, no events, does time still exist? Some physicists argue that time is just a way of describing change. If change ceases, time might as well not exist. In this view, the end of time wouldn't be a sudden event, but rather a gradual process where the universe fades into an eternal stillness. But what if time doesn't just fade away? What if it undergoes a dramatic transformation? Time reversal. Could time run backward? One of the strangest ideas in physics is that time might reverse at some point in the future. Some cosmologists believe that if the universe stops expanding and begins to collapse, entropy could reverse and time might start running backward. If this were to happen, what would it look like? Would we experience life in reverse, with people growing younger instead of older? Or would our memories and consciousness also be reversed, making us unaware of the shift? Some theories suggest that if time reversed, we wouldn't even notice, because our thoughts, experiences, and awareness would also be moving backward. From our perspective, everything would seem normal. However, most physicists believe that entropy's increase is irreversible, making a full-scale time reversal unlikely. The quantum perspective: time as an emergent property. In the world of quantum mechanics, time behaves strangely. Some theories suggest that time is not fundamental, but rather a property that emerges from deeper physical processes. For example, in some interpretations of quantum gravity, time isn't continuous but is made up of tiny discrete units, similar to how a movie is made up of individual frames. If this is true, then time may not be a smooth flow, but rather a series of quantum events stitched together by our perception. If time is an emergent property rather than a fundamental force, then it could theoretically stop under certain extreme conditions, such as at the singularity of a black hole or in the final moments of the universe. Is time an illusion? Some physicists and philosophers argue that time might not exist at all, at least not in the way we perceive it. One of the most radical ideas comes from the block universe theory, which suggests that all moments in time, past, present, and future, exist simultaneously. If this is true, then time doesn't flow. Instead, we are simply moving through a pre-existing landscape of events. If the block universe theory is correct, then the end of time might not be an event in the future. It might already exist, just like every other moment in history. What happens after the end of time? If time does have an end, what comes after? Does reality itself cease to exist, or does something beyond time take over? Some speculative theories suggest that the end of time could lead to the birth of a new universe. In this view, our universe may be just one in an endless cycle, where each universe ends and gives rise to another. If this is true, then time is not something that disappears, it simply resets. Others propose that if time ceases, consciousness might transition into a state beyond time, one we can't currently comprehend. If time is something our brains create to organize reality, then perhaps the end of time would be the ultimate liberation, freeing awareness from the constraints of past, present, and future. Final questions. Before the conclusion, if time is an illusion, what does that mean for our lives? If time has an end, what happens next? And if we ever discover the true nature of time, will it change the way we live? As we approach the final part of this journey, we must ask, what if everything we know about time is wrong? After exploring the mysteries of time, its measurement, relativity, perception, and even its possible end, we are left with one final question. What if everything we think we know about time is completely wrong? Time has always been a mystery. From ancient civilizations tracking the stars to modern scientists bending the fabric of space-time, our understanding of time has evolved, but it is far from complete. Even today, we are discovering new aspects of time that challenge everything we once believed. What if time doesn't exist? One of the most radical ideas in modern physics is that time might not exist at all, at least not in the way we experience it. Some scientists believe that time is not a fundamental force of the universe, but an illusion created by our brains. In quantum mechanics, particles behave in ways that defy our normal understanding of time. They can be in multiple places at once, move backward and forward in time, and even exist in a state of superposition, where all possible outcomes exist at the same time until measured. This raises a profound question. If time doesn't exist at the smallest levels of reality, then is our experience of time just an illusion? Some physicists propose that time is a result of emergence, meaning that it only appears to exist because of how we observe the universe. If we could step outside our limited human perception, we might see that past, present, and future are all equally real, happening at once. This idea aligns with the block universe theory, which suggests that the past hasn't disappeared, and the future isn't something we are waiting for. It all exists simultaneously. In this view, time isn't something that moves, it's something we move through. But if time is just an illusion, then what does that mean for our lives, our memories, and even free will? Are we living in a predetermined timeline? If all moments in time exist at once, does that mean we are trapped in a predetermined path? Do we truly have free will, or are we just following a script that has already been written? Some physicists argue that if the block universe is real, then the future is just as unchangeable as the past. No matter what choices we think we are making, the future already exists, and we are simply experiencing it as we move forward. Others believe that quantum mechanics allows for multiple futures. According to the many worlds interpretation, every possible choice creates a new branching timeline, meaning that all possibilities exist, but we can only experience one. If this is true, then our choices do matter, not because they change the future, but because they determine which version of the future we experience. What if time is a simulation? Another possibility is that our reality, including time, is a simulation. We explored this idea earlier with simulation theory, which suggests that an advanced civilization may have created our universe as a digital construct. If time is part of this simulation, then it isn't a fundamental property of reality. It's just a programmed rule within the system. In a simulation, time could be manipulated, paused, or even rewritten. But if we are living in a simulation, could we ever break free? And if we did, what would we find outside of time? The ultimate question: what exists beyond time? If time is an illusion, then what happens when it ends? Is there something beyond time, something we cannot yet comprehend? Some theories suggest that consciousness itself might not be bound by time. Near-death experiences, altered states of awareness, and deep meditative states have all led some to believe that there may be a realm beyond time, one where past, present, and future merge into a single, timeless existence. If time is something our brains create, then perhaps the ultimate mystery is not time itself, but the nature of consciousness. If we could step outside time, would we discover a greater reality, one where existence is not measured in seconds, years, or lifetimes, but simply is? Final thoughts. Time remains one of the greatest mysteries of existence. Whether it is an objective reality or just an illusion, it shapes everything we do. It governs the stars, our bodies, our minds, and our very perception of existence. Even if we never fully understand time, one thing is certain: our time is limited. Whether time flows endlessly or is simply an illusion, our experience of it is fleeting. That is what makes each moment valuable. So perhaps the greatest lesson we can learn from time is not how to escape it, but how to make the most of it. Because whether time is real, an illusion, or a simulation, the moments we live in are all we truly have.